Hi, dear students. I'm Dr. Arun Kumar, Associate Professor, Department of Mathematics, Sai Vidya Institute of Technology. So in this video, I'll be discussing about the method of finding directional derivative. So in short form, I can call it as DD of a given scalar function in some directional vector. So the formula to find the directional derivative is given by DD equals, it is grad phi dot n cap. So this is the formula which calculates the directional derivative, where grad phi, the gradient of phi, we know it can be defined like this. It is dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. And the n cap is nothing but it is vector d by its magnitude. Vector d by magnitude of d, where d stands for the direction vector. So this is the formula to find the directional derivative, where the necessary quantities are defined here. So let us understand how to find a directional derivative of a given scalar function. So through certain examples. So I'll start with the first problem. Find the directional derivative of x square yz cube at the point 1, 1, 1 in the direction I plus j plus 2k. So this is the problem given. So here I can take the given scalar function as phi. So let us choose phi equals the scalar function given, that is x square y z cube. So this is phi. So the point is 1, 1, 1 they have given, and the direction vector is vector d is nothing but it is I plus j plus 2k. So this is the direction vector given. Now we know to find the directional derivative, I need gradient of the scalar function grad phi and n cap, where n cap is vector d by magnitude. So let us calculate one by one. So we know that grad phi is nothing but the formula is it is dou phi by dou x into I cap plus dou phi by dou y into j cap plus dou phi by dou z into k cap. So this is equal to dou phi by dou x, means we need to differentiate this phi partially with respect to x first. So, differentiation of this with respect to x means differentiation of x square was 2x, whereas this y and z cube are constant. So it becomes 2x y z cube into I cap plus next term is dou phi by dou y. So y means this x square and z cube is constant and differentiation of y was 1. So it becomes just x square z cube into y is 1. So j cap. Plus the last term it is dou phi by dou z. So with respect to z means, these two terms are constant, x square y. Whereas differentiation of z cube, it is 3z square. So together I can write this as 3x square y z square into k hat. So this is our gradient of phi. So differentiate this phi partially with respect to x, y, and then z, substitute here. Now I need the value of grad phi at the point 1, 1, 1. So this implies grad phi at 1, 1, 1 is nothing but, let us put x is equal to 1, y is equal to 1, and z is equal to 1. So we get, see, this is 1, 1, 1 cube is also 1. So it becomes 2 into 1 into 1. So it becomes 2, 2i. Plus next, if I put 1 here, 1 square is 1, and here also 1, 1 cube is 1. So it becomes 1 into j. So that is j hat. Plus the last term, if I put 1, so 1 square 1, and here also 1, here also 1 square 1. So it becomes just 3, 3k. So this is our grad phi at a given point. So next, I need the value of n cap. So we know that n cap is nothing but it is vector d by its magnitude. So this is nothing but it is I cap plus j cap plus 2k cap by the magnitude, means it is square root of. So this term, the coefficient of I, that is 1 square, plus coefficient of j, that is 1 again, 1 square, plus coefficient of k, that is 2 square. So it is 1 square plus 1 square plus 2 square So this gives n cap equals, it is I plus j plus 2k hat divided by, so this is 2 square is 4, 4 plus 1 5, 5 plus 1 6, so it is root 6. So this is our n cap. So we got grad phi and n cap. So therefore the directional derivative is nothing but it is grad phi dot n cap. So just take a dot product of these two, grad phi and this. So it is 2i plus j plus 3k hat dot, it is I plus j plus 2k divided by square root of 6. So this is equal to, so 1 by root 6, I'll take it outside. So take a dot product now. So I dot I. So it is 2 into 1, 2 plus multiply j terms. So 1 here, 1 here, 1 into 1, 1 plus this is k terms, 3 into 2, 6. So this implies the directional derivative is equal to 6 plus 3, it is 9, 9 by root 6. So this is the directional derivative of the given problem. This is how we can find a directional derivative of a given scalar function with respect to a vector here. So this is a common procedure for every problem. I'll take one more problem of the same type. So find the directional derivative. I'll write short form DD, the directional derivative of xy is equal to z square at 4, 1, 2 in the direction of, I'll write 3, 3, minus. So it is a little bit different one. So same procedure, same thing, but here instead of giving a direction vector, they said in the direction of this, it is a 3-coordinate system, and here the x coordinate is 3, y is 3 again, z is minus 3. That means I coordinate is 3, j coordinate is also 3, k coordinate is minus 3. Together I can write a direction vector for this. So first I'll write the scalar and the direction vector. So let us choose phi equals. So you know phi is xy is equal to z square is given. You take the z square to the left hand side. So it becomes xy minus z square. This is the scalar function. And the direction vector d is nothing but, so it is 3, 3 minus 3. So it becomes 3i plus 3j minus 3k. So this is the direction vector of a problem. Now we have to find the gradient of this phi at this point 4, 1, 2. Then we have to calculate what is n cap, vector d by magnitude of d. So let us find that. So this implies, grad phi is nothing but it is dou phi by dou x into I cap plus dou phi by dou y into j plus dou phi by dou z into k hat. So let us differentiate this phi partially with respect to x, y, z and substitute here. We'll get what is grad phi. So I'll differentiate and substitute. I'll just go to the next page now. Next page. Yeah. So this implies grad phi equals first dou phi by dou x. So if I differentiate this term with respect to x, so differentiation of x is 1, 1 into y, it is y, and this term becomes 0. So it becomes y minus 0 I cap. So it is y I cap. Next plus dou phi by dou y. With respect to y means differentiation of y is 1. So it is x into 1 x, and this term becomes 0. So it is plus x into j. And next term with respect to z means the first two term becomes 0. There is no z here. Whereas differentiation of z square is 2z. So it's 0 minus 2z. It gives minus 2z k hat. So this is our grad phi. So now I want grad phi at the point. So the point here is 4, 1, 2. So it is 4, 1, 2. This is equal to. So if I substitute y is 1 here, so 1 into I, it is I cap. So x is 4 here, so it is plus 4j, and z is 2, 2 to the 4, it is minus 4k hat. So this is our gradient of phi. So now n cap, n cap is, it is vector d by the magnitude of vector d. So this is equal to, so we know vector d is this 3i plus 3j minus 3k. So it is 3i plus 3j minus 3k divided by magnitude of this. So the square root of 3 square plus 3 square plus minus 3 whole square. So this gives, so I can take 3 common here. So it is I cap plus j cap minus k cap divided by denominator. It is square root of, so 3 square is 9, 9 plus 9 plus, and minus 3 whole square is also 9. So it becomes 27, and 27 can be written as 3 root 3. So it is 9 into 3, root 9 is 3. So it becomes n cap equals, it is 3 into I cap plus j minus k hat divided by, this is 3 root 3. So therefore 1 3 gets cancelled. So finally we get n cap equals, it is I plus j minus k divided by square root of 3. So this is our n cap. So this is our n cap. So I got the value of grad phi and n cap. So therefore the directional derivative is dd is nothing but, it is grad phi dot n cap. So now let us take a dot product of these two vectors. So it is I cap plus 4j minus 4k hat dot, it is I plus j minus k divided by root 3. So this is equal to, I can take 1 by root 3 outside. So take a dot product now. I dot I, it is 1. Next 4j dot j. So it becomes plus 4. Then minus 4 minus 1. It becomes plus 4 again. So this becomes 4 plus 4, 8, 8 plus 1, 9. So it becomes 9 by root 3. So the directional derivative of this one is 9 divided by square root of 3. So this is how we can find a directional derivative of any problem here. So this is a common procedure for all problems. Thank you.